Okay, class. What we're going to be looking at today is arithmetic sequences and series. Previously, we talked about just any sort of sequence. Today, we're going to be kind of really focusing on an arithmetic sequence. What is an arithmetic sequence? How do we write rules for arithmetic sequence? How do we find the sum of a bunch of numbers in an arithmetic sequence? So let's start off by defining what is an arithmetic sequence. When we were looking at data, we could say it's linear if the first differences were constant. And that's what an arithmetic sequence is. An arithmetic sequence is basically linear data. It's sequences where there's a constant difference between each consecutive term. And we call this common difference, we use the letter D for the common difference. So we have right here an arithmetic sequence. We see that between every single term here, it's plus 500. So in this case, we say that D is 500. That is our common difference. And we say that because of that, we call this an arithmetic sequence. Okay, so why don't you go ahead and for the next four sequences, determine are they arithmetic or are they not. So I'll pause it right here and I'll begin back in 1, 2, 3. Okay, here are the solutions. Everyone is arithmetic except for number 3. It looks like it is plus 3, but we see right here it's only plus 2. Now, we have a way of writing the rule for arithmetic sequences very easily with a little formula here. And I like to understand the meaning of this. The way I think about it is, I could find the nth term of a sequence by starting with the first term, adding my common difference n minus 1 times. And we could see that this is a linear equation. We just have this single n term raised to the first power. Let's see how we use it now. Here's an arithmetic sequence, plus 3, plus 3, plus 3, plus 3. Our common difference is 3. Our first term is 4. So we could start off by saying I could find the nth term by starting with the first term. And I'm adding 3 to it n minus 1 times. So I can now distribute the 3 across this, and I could simplify to 3n plus 1. And this looks like a linear equation right here, and it is. I'm okay in either form. Both of these are perfectly fine equations. Sometimes it's nicer to leave it like this, but either way. So go ahead on your own, do this. Write out the rule for the nth term of this sequence. We'll pause it here. 1, 2, 3. Start up. Starting from 7, adding my common difference n minus 1 times. I simplify it to 4n plus 3. Now we need to find the 15th term. We say a 15 is equal to 4 times 15 plus 3. That's equal to 63. I always like to check this rule here. When especially if I do some simplification, I want to check it out. I'm going to start with the first term. I'll say, is A1 equal to, the first term 7? Yes, it is. Is my, say, last term here, this is my fourth term, 1, 2, 3, 4. Is my fourth term equal to 19? Yes, it is. So that makes me feel good about this rule. I didn't kind of mess up when I was plugging things in. I didn't mess up when I was simplifying things. Okay, now let's work on a different kind of problem where, in this case, we know the 10th term, but we don't know the first term. We know the common difference is 4, and we want to write a common rule, but again, we don't know the first term. That's our unknown. If we have one unknown, we need one equation to find one unknown. So let's see how we could make that one equation. So I know my common difference is D. it's kind of like my slope, my common difference. My 10th term, this is like my y value, my x value. My y value is 52. My x value, my input, is 10. So I plug 10 right in here. And then I have my equation. Solve for my unknown. B1 is 16. So now I can write my general equation that the nth term is equal to the starting term, 16. And I add my common difference, which is 4, n minus 1 times. Okay. A different kind of problem. Say I have two unknowns. I don't know my first term, and I'm not given my common difference. So if I have two unknowns, I need to have two equations in order to solve those two unknowns. But in this case, it says I have an arithmetic sequence, and I have these two data points. The fifth term is negative 43. The 12th term is negative 8. So in that case, we could say if the fifth term is negative 43, that means for n is equal to 5, a5 is negative 43, and we can write that as an equation here. Negative 43 is equal to a1 plus my common difference, 5 minus 1 times. We write out our second equation. Now I have two equations, two unknowns, and I just solve it kind of using my normal methods. In this case, it's very straightforward to do elimination. I'm just going to subtract the two equations, and I get the following. This you can see here, this is 4 right here, minus 11 right there. And so now I'm going to solve for d. I get d is 5. I'm going to plug it back into one of my equations. I'll use the second equation. It looks a little bit easier with the negative 8. Negative 8 is equal to a1 times, or a1 plus 5 times 11, and I solve for a1. Now I found my two unknowns. I found my first term. I found my common difference, and now I could write out my equation. Again, we start off with the first term. We add the common difference, n minus 1 times. And I could go forward and simplify it to a standard form if I want. Okay, let's talk about arithmetic series now. And if you remember, a series is a sum of numbers in a sequence term. Today we're just talking strictly about arithmetic series. So that means that in this case right here, AI is referencing an arithmetic sequence. So what it says is, if I want to find the sum of the first n terms, the way I do that is, Sn here stands for the sum of n different terms. N here stands for how many terms I'm adding up. A1 stands for the number of terms, or sorry, the first term that I'm in my sequence. And an stands for the last term in my sequence. So what I like to do, I like to think of it like this. I'm averaging the first and the last terms, and once I find that average, I multiply it by the number of terms that I'm adding up. And this works for any arithmetic sequence, whether I'm starting from the first term or any other term. So suppose I have the sum of, let's start with I is equal to 5 to 10, of some arithmetic sequence. And in this case, bi, let's use I here. This is equal to just, this is an arithmetic sequence. I'm adding up terms 5 through 10. So what I do is, I want to find the average of the first term all the way to the last term. And in this case, the first term is term number 5. So the fifth term to the 10th term, find the average, and then multiply it by the number of terms that I'm adding up. Now let's be careful here. It is not 10 minus 5. 5, 6, 7, 8, 9, 10. There are 6 terms there. So pretty simple, straightforward formula. I like to think of it again as first term, last term, find the average, multiplied by the number of terms. So example here. This is an arithmetic sequence. First off, how do we know it's an arithmetic sequence? Well, arithmetic sequence is linear. This looks like a linear equation. So we can use this kind of formula here to add up the first 20 terms. So in this case, n is 20. The first term, let's plug in 1 in here. We get 10. And then here we need to find the last term, which is the 20th term. We plug in 20 here. We get 67. So I'm going to find the average of these two terms and then multiply it by how many terms I'm adding up. And I get my answer of 770. Okay, I'm going to pause it again, do these. Unpause in 1, 2, 3. We find that our rule is negative 5n plus 106. Let's find the sum of the first 20 numbers. We get 1070. Okay, that's it for today's lesson. Have a good day, everybody.